Hello, everyone. So let's discuss the bottom-up strategy of doing the same problem. So this is the last, the strategy where where we said that instead of using a top-down approach of recursion, we can simply use loops using, iterative approach to solve the same problem. But now this isn't necessary. Like you can encounter some problems where those problems are only breakable or solvable using recursion, but most of the problems that we will see are the problems that can be solved both using recursion or using iteration that we are going to see now. So in terms of iterative solutions for this for this Fibonacci sequence, instead of following top-down approach where we start from nth number and then go towards our base cases, we can actually start from our base cases using a bottom-up strategy. Okay, so start from first two numbers and then add whatever the first two numbers are to get your third number, add whatever the third and second number add whatever the third and second numbers are to get your fourth number, and likewise so on and so forth. Continue adding the previous two numbers until you reach your n. Okay, so you can have a loop where you can simply add previous two numbers to get the your nth number, and you stop at whatever the value of n is. So in this case, we call this a bottom strategy, since we start from our base cases and move up until we reach n. Now, obviously, in this loop, you will have a loop which iterates over iterates over an element. So you'll have the time complexity, a linear time complexity in this case, dependent upon whatever your number is. In this solution that I have maintained, I am maintaining an array, so which means that I'm actually keeping record of whatever the n numbers are that I've encountered until that sequence. So therefore this has the complexity of order of n, the space complexity of order of n, but you don't need to maintain this whole array. I only want whatever the number, the ninth number is. Okay, I'm not asking you to give you all the previous numbers, so therefore you don't need to maintain this array where you'll save each Fibonacci number. Okay, so you could have a space complexity of order of 2, just because you only need to track the last two numbers in order to get your nth number. Okay, so instead of maintaining this array, just maintain the last two numbers and you'll get your current number. Okay, so in this way you can have a space complexity which is even less than order of n. Okay, so like in this case, the bottom-up approach is almost as good as as the memoized recursion in some sense, but it depends upon there are some cases where uh, where you can have a better time and space complexity in memoized approach than, for example, in tabulated approach. Okay, so we are going to solve in our live class we are going to solve, let's say, another problem or maybe a couple of problems using these three approaches that we have mentioned: a simple recursion, a dynamic way, or let's say memoized recursion, or a simple tabulated way of doing things. Although this is also somewhat difficult to comprehend. Depends upon your study. Some problems are easier to represent as a recursion, while some are easier to represent as an iterative framework. So we'll see a couple of problems in our live class as well.